visa issue, but we are very glad that we could do it this online presentation. Louphou, the floor is yours. You have sort of 30 minutes to present the paper, and then after we have Lawrence, Christiano discussing the paper for you. Thank you very much.
Thank you. Thanks a lot for the invitation. I'm very happy to be able to present online today. So this is a joint paper with Javier, and the motivation for this paper is the disconnect that exists between the predictions of standard macroeconomic model and what we see central banks, especially in the emerging markets, do in practice. For example, if you take virtually any open economic model with some nominal frictions, then the standard prediction is that it is optimal to follow a flexible exchange rate regime. And the logic in this class of model follows this Friedman's idea that the exchange rate usually serves as a shock absorber, meaning that if a negative shock pushes the economy toward a recession, then an exchange rate depreciation can help shift expenditures toward domestically produced goods and help alleviate the recession. However, when we go to the data, we see that many central banks that call themselves floaters are actually very reluctant to let their exchange rate fluctuate. This phenomenon has been documented by Carl von Renat in the 2002 QJ paper, and labeled this phenomenon the fear of floating. Now, what we argue with my co-author is that despite a lot of progress and a lot of debate on this issue, we still don't have a very good understanding of why is it the case that central banks are so reluctant to see the exchange rate float. And in this paper, what we do is to provide a theory where the fear of floating will emerge as an optimal outcome. And to do that, we develop a very simple model with two main ingredients. The first one is the presence of nominal rigidities, which is the standard ingredient in the Mundell-Fleming tradition, that will call for a flexible exchange rate. And on top of that, we will have also the presence of an occasionally binding borrowing constraint linked to the real exchange rate, which will prevent households from borrowing more than a single fraction of their current income. And this second friction will also give rise to the possibility of self-fulfilling financial crisis. Using this very simple model with these two ingredients, we show that by stabilizing the nominal exchange rate, a central bank can help prevent self-fulfilling financial crisis and avoid contractionary depreciation. And in terms of welfare, it's optimal for a central bank to stabilize the exchange rate. In the last part of the talk, if I have the time, I will also introduce the policy rule that we design in order for central banks in emerging market economies to implement the efficient allocation without having this fear of floating. For the sake of time, I'm going to skip the literature review. The only paper that I want to point out here is the paper by Schmidt, and Uribe, in which they show that in model with occasionally bounding collateral constraint, there are possibility of multiple equilibria, and we are going to build on that. So let me just jump to the model. The basic model is going to be deterministic. Households have preferences over consumption and money holdings. And the consumption good here is going to be a CS aggregate of tradable consumption and non-tradable consumption. The parameter gamma here will represent the elasticity of substitution between tradable consumption and non-tradable consumption. In each period, an household will receive an endowment of hours, H bar, and an endowment of tradable YT. For tradable goods, we are going to assume that the law of one price holds, which means that the price of tradable in the domestic currency will be equal to the price of tradable in the foreign currency once we take into account the nominal exchange rate. And because here we focus on the small open economy model, the price of tradable in the foreign currency will be taken as given, and we are going to normalize this price to 1, which means that in this environment, the price of tradable will be equal to the price will be equal to the nominal exchange rate. For the non-tradable goods, we are going to assume that it's produced by firms using a linear technology in labor. For the welfare analysis, however, we are going to take the cashless limit. So we are going to take the limit where this coefficient chi, which capture the liquidity services of money holdings, will go to 0. So here's the problem of the household. The household is going to maximize their life, and household is going to maximize its lifetime utility, subject to 2 constraints. The first one is going to be the budget constraint, and the second one here is the collateral constraint. On the left-hand side of the budget constraint, we have expenditures in tradable, expenditure in non-tradable, the beginning of period money holdings, and some debt in domestic currency and debt in foreign currency. So the left-hand side here represents the total expenditure of an household, and the right-hand side will represent all the sources of revenues. Revenue from tradable, which here is represented by these 2 terms, where PT is the price of tradable, labor income, beginning of period money holdings, some borrowing, and some transfers from the government. For the foreign currency bond that I mentioned at the beginning here, we are going to assume that it pays an exogenous interest rate R. And for the domestic currency bond, it's going to pay an endogenous interest rate R tilde, which is set by the central bank. And household in this economy will also be subject to a borrowing constraint, which limits the total amount of borrowing to a fraction kappa of the current income. So here, the borrowing here is in foreign currency. So BT plus 1 is if we take the case of South Africa, BT plus 1 is the debt in dollars. ET is the exchange rate, and with ET, you convert that in the local currency. And the right-hand side is the total income of the household in the domestic currency. For simplicity, we are going to assume that the net supply of domestic currency bond is 0, which will allow us to avoid indeterminacy in terms of the portfolio in equilibrium. Right. On the firm side, we assume that firms produce using only labor production. They produce with this constant return to scale technology. So the optimality condition is well known. The price will be equal to the wage in equilibrium. Now, here is how we introduce nominal rigidity in this economy. We assume that there is a downward nominal wage rigidity constraint, so it's characterized by this constraint, which says that the wage cannot fall below its previous period level. So the implication of this downward wage rigidity constraint is twofold. The first one is that, so what I mean is that 2 things can happen when you have this downward nominal wage rigidity constraint. Either the economy is at full employment, in which case the wage constraint does not bind, or the wage constraint binds, and in that case, the economy will experience involuntary unemployment. Finally, the last economic agent in this model is the government. The government here is going to just set money supply and use transfer to balance its budget. So in terms of market clearing, because we assume that domestic currency bond the net supply of domestic currency bond is 0. The demand for non-tradable will be equal to the supply of non-tradables in equilibrium. Hours worked will be equal to the demand for hours, and the money supply here will be equal to the demand for money. This is the market clearing for domestic currency bond. Now, to fix ideas and to make sure that the model is well defined, I'm going to define an equilibrium here. So an equilibrium is defined as follows: given an initial condition, B0, which is the initial debt position in foreign currency, and a previous period's wage W minus 1, An equilibrium is a sequence of government policies and prices and also allocations such that households and firms are going to optimize, markets are going to clear according to the following equations that you have up here, and the wage rigidity constraint and the rationing conditions on the labor market are going to hold. Now, let me jump to the main analysis here. So here's the roadmap. I'm going to first talk about the multiplicity even in the absence of nominal wage rigidity. Then I'm going to put back nominal rigidity and explain how monetary policy can affect the vulnerability to self-fulfilling crisis. Then I'm going to talk briefly about contraction depreciation and sophisticated policies in order to avoid self-fulfilling financial crisis in emerging economies. So for the analysis, let's start with the borrowing constraint, which is one of the key frictions in this model. Here, what I'm doing is to rewrite the borrowing constraint in terms of in unit of tradables, so in terms of the foreign currency. So here you have total debt in dollars, and here you have the income, let's say in dollars. And here the key again is the fact that the labor income enters in the constraint. So what I'm going to do is to use equilibrium conditions and optimality conditions to substitute this labor income into this constraint. So the first line here represents the optimality conditions of firms and households. And the second line here represents the market clearing condition. Demand for non-tradable has to be equal to production. And this is the balance of payment identity equation. So once I substitute these equations into this constraint, what I get is the following constraint. So what I'm doing here is to use the right-hand side and to rewrite the right-hand side. So if I rewrite the right-hand side of the borrowing constraint, what I found is that this right-hand side, which is the maximum level of borrowing of an individual household, is a function of the aggregate level of debt and the aggregate level of borrowing. In particular, it's going to be decreasing in the aggregate level of debt and increasing in the aggregate level of borrowing. So to give you an intuition of why this can lead to a situation where a higher consumption can lead to real appreciation and relax the borrowing limit, let's go back to these equations here. Assume, for example, that the economy is at full employment, which means that demand for non-tradables is equal to H bar, the maximum hours that household can work in this economy. Then once you have higher consumption, because households are borrowing more, this is going to lead to an increase in the relative price of non-tradables. And because the real wage is exactly equal to the relative price of non-tradables, this means that the constraint here is going to be relaxed. And that's the second also result that we have here. So now I'm going to define a steady state equilibrium using this notion of the endogenous borrowing limit that I derived in the previous slide. To define a steady state equilibrium, we need two assumptions. Output is constant and beta I equals 1. Then we denote by B hat the fixed point in the borrowing limit when hours worked is equal to H bar. Then the first lemma in the paper is that if the economy starts with an initial debt level that is less than B hat, then a steady state equilibrium will exist, and it is optimal for the government to implement full employment. Now, how the government is going to implement full employment full employment can be implemented with many different kind of policies here. So what we are going to do is to focus on the monetary policy that will implement this full employment with no inflation. So once we do that, we can define what we will call E bar and M bar. E bar will represent the level of the exchange rate, which is consistent with full employment at a steady state with zero inflation. And M bar is the level of money supply that will also implement the full employment equilibrium at a steady state with no inflation. Here, what I'm doing is to give an intuition for the first lemma here, why a steady state equilibrium exists when B0 is less than B hat. So B hat here is the fixed point in the borrowing limit here. So it's the intersection between individual borrowing limit and the 45-degree line. So what I'm plotting here is individual borrowing as a function of aggregate borrowing. So an equilibrium here by consistency has to be on the 45-degree line, and the intersection here between the steady state level of borrowing and the 45-degree line represent the fixed point. On the right-hand side of this fixed point, meaning that the economy starts with an initial debt level that is greater than B hat, and at the steady state, the aggregate borrowing is equal to this initial debt level, which is greater than B hat. Then individual household in the equilibrium will also borrow this level of debt, which is above the borrowing limit and will violate the borrowing constraint. And that's why when B0 is greater than B hat, a steady state equilibrium does not exist. If the economy starts with an initial debt level that is less than B hat, then you can see that individual household will borrow B0 too, and the borrowing limit will still be above individual what household are borrowing, and this means that the constraint is not binding. Now, what Schmidt-Groh and Uribe show in their paper is that when the slope of this borrowing constraint is greater than 1, meaning that an increase by $1 of aggregate borrowing can lead to an increase in the borrowing limit of an individual household by more than $1. This opened the door to the possibility of self-fulfilling financial crisis. And here, what we are going to make as an assumption is an assumption on parameters. We are going to assume that the set of parameters is such that at the fixed point B hat, the slope of the borrowing constraint is greater than 1. And this will be a sufficient condition for the existence of a non-empty region, that region for which the steady state equilibrium for which the self-fulfilling financial crisis equilibrium will exist. And we are going to focus on the case where gamma is less than 1. And here is an illustration of this result. So let's say let's say here that the exchange rate is, the wage is completely flexible. So the hours worked is equal to H bar. There is no downward wage rigidity constraint. Here I'm plotting here, in addition to the steady state borrowing limit and the 45-degree line, I'm plotting the borrowing limit of an individual household at a generic period 0. Then this individual borrowing limit, as I showed before, is going to be decreasing in the debt level of aggregate debt level, increasing in aggregate borrowing. Let's say the economy starts with an initial debt level that is exactly equal to B hat. Then at this point, we know that the constraint holds with equality. We have a steady state equilibrium, which is represented by the point G here. And the slope of the borrowing constraint is greater than 1 because of our assumption 1. Now, let's say the economy starts now with B0 slightly less than B hat. So what will happen is that we have one steady state equilibrium where the constraint does not bind. Now, if B0 is sufficiently close to B hat by the neighborhood argument, meaning that let's say B0 is very close, it's B hat minus epsilon, then the slope of the borrowing constraint at this point here is going to be greater than 1, which means that in addition to the steady state equilibrium, we'll have a second equilibrium because we have two curves here, one curve where for which the slope is equal to 1, which is the 45-degree line, and the other one for which the slope is greater than 1, which is the borrowing limit. So we'll have another intersection, and this other intersection is another equilibrium where the constraint now binds, and B0 is less than B hat. So when B0 is less than B hat and sufficiently close to B hat, what we are showing here is that we have two equilibria. One where the constraint does not bind, and another one where the constraint binds. And this second equilibrium will exist because the slope of the borrowing constraint is greater than 1, which means that any coordinated action of household when they start with B0 less than B hat can lead to a situation where the constraint is going to bind, even if there is another equilibrium where the constraint does not bind. And another characteristic of this equilibrium is that you have B1, which is less than B0, how much household borrow relative to the initial debt level, which means that we'll have capital outflows in this economy, and aggregate consumption is going also to fall. So you have all the characteristics here in this equilibrium F of a financial crisis: capital outflows, aggregate contraction in aggregate demand, and you'll also have real depreciation
in the economy. So we are going to refer to the second equilibrium here as self-fulfilling financial crisis equilibrium. Now, the question that we ask in this paper, and that's the main objective for the paper, is to kind of understand how monetary policy will affect the debt region for which we can have this intersection here. So how monetary policy would affect the possibility of self-fulfilling financial crisis in the presence of nominal rigidities. And that's what I'm going to do next. So for that, we are going to assume now that wages are down, we have wages are downwardly rigid, and we are going to consider two monetary policy regimes. The first one is going to be a monetary policy regime in which the exchange rate is flexible, and the second one is a monetary policy regime in which the exchange rate is fixed. For the flexible exchange rate regime, we are going to also consider two cases. One in which the central bank is going to fix money supply and let the exchange rate be determined endogenously. And the second one where the central bank is going to target full employment and let the exchange rate fluctuate freely. In the fixed exchange rate regime, the central bank is going to announce the exchange rate, which here is going to be equal to the efficient level of the exchange rate, and commit to that. And here the analysis will focus on how it's going to affect the possibility of self-fulfilling crisis. So here the exchange rate is going to be determined by the money demand equation and the interest parity condition. And what we show in the paper is this lemma. We show that with fixed money supply, when the exchange rate can float freely and we have fixed money supply policy, then the exchange rate in the self-fulfilling crisis equilibrium, when it exists, is going to depreciate and the economy will experience involuntary unemployment. We try to characterize the debt region for which a self-fulfilling financial crisis can coexist with the steady-state equilibrium when the economy starts with an initial debt level that is less or equal to B hat. And what we show is that when we have fixed money supply, because of the complementarity between the depreciation of the exchange rate and the deleveraging in the economy, we have actually two self-fulfilling financial crisis equilibria that coexist with the steady-state equilibrium. And we characterize the debt region for which we have only the steady-state equilibrium, two self-fulfilling financial crisis equilibria that coexist with the steady-state equilibrium, and one self-fulfilling crisis equilibrium. In particular, what we show is that if the economy starts with an initial debt level that is higher than the endowment of tradable and how much the economy can lever on the endowment of tradable, which is 1 plus kappa YT, then only one self-fulfilling crisis equilibrium coexists with the steady-state equilibrium. I'm going to refer to that as the high debt level region. Then in the intermediate debt region, where the economy starts with an initial debt level that is less than the endowment of tradable and how much the economy can lever on that, you have actually two self-fulfilling financial crisis equilibria that coexist with the steady-state equilibrium. And in the low debt region, only the steady-state equilibrium exists. We have the same characterization with full employment policies. Now, with fixed exchange rate, what we show is that when the economy, when the central bank can fix the exchange rate, then the relative price becomes exogenous. The maximum borrowing limit of an individual household becomes linear in the aggregate debt limit, and only one steady-state equilibrium can coexist with only one self-fulfilling financial crisis equilibrium can coexist with the steady-state equilibrium. And what we show is that actually the crisis region on the fixed exchange rate is smaller than the crisis region on the flexible exchange rate. So here is the plot that I skipped 2 slides ago, and I'm going to explain that here. So here what I'm showing is, instead of having the self-fulfilling crisis equilibrium as a function of, for a given initial debt level, I'm plotting the policy function. And what you can see here, for the dotted black line, it's the steady-state equilibrium. It has all the properties that we know. And borrowing is going to be increasing in debt, consumption is going to be decreasing in debt, and the exchange rate and employment is going to, the economy will be at full employment in the steady state and everything. The red one is the equilibrium, the self-fulfilling crisis equilibrium when we have fixed money supply, and the green one is with full employment. And you can see that the debt region is larger when the central bank announced that they are going to target full employment. It's relatively smaller when the central bank announced that they are going to fix money supply. And it's even smaller when the central bank fix the exchange rate. So a direct implication of this graph, of this policy function here, is that if you're a central bank and you are in this debt region, meaning that your initial debt is less than 1 plus kappa YT, how much endowment of tradable you have and how much you can live on that. If you don't have enough debt, if you don't have enough resources to repay your debt at the beginning of the period, then you want to fix your exchange rate. And that's the first normative result that we have in the paper. So what we show is that if an economy starts with an initial debt level that is less than 1 plus kappa YT, then a fixed exchange rate is going to welfare dominate a flexible exchange rate. And it doesn't matter whether the central bank is going to fix money supply or set a target in terms of employment or fix the nominal interest rate. So now that we have this normative result, another question that we asked in the paper is whether the fact that we abstract from the possibility of fundamental shock matters for this result. So what we are going to do next is to introduce fundamental shock in the model, solve it quantitatively, and compare two different regimes: a flexible exchange rate regime and a regime in which the central bank is going to try to stabilize the fluctuation in the nominal exchange rate. So to do that, we focus on this formulation of the monetary policy regime, in which the exchange rate is going to depend on the deviation of money supply from the efficient level. So we in order to have like a well-defined formulation here, we consider the stock of money over GDP. And what we do here is that in the bad equilibrium, what I'm going to define as a bad equilibrium is an equilibrium criterion. So to make sure that everything is clear here. So here, what we do is the following. We know that there is a possibility of multiple equilibrium in this economy. So we need to have an equilibrium selection criterion when we solve the model quantitatively. So we are going to consider two equilibrium selection criteria. The first equilibrium selection criterion is going to be the fact that if an equilibrium in which the credit constraint binds exists and it satisfies all the equilibrium conditions, we are going to select this one first. Now, if it does not exist, then we are going to consider the case where the constraint does not bind. So this is a situation where household always select, or let's say it's a situation where you always select the bad equilibrium when it exists. In the second one, we are going to focus on selecting the equilibrium where the constraint does not bind first. So this one is going to be the good equilibrium where it's exactly like in the steady state equilibrium that I showed before. You are always in the best equilibrium, and when it does not exist because some optimality conditions are not satisfied, we are going to select the one where the constant binds. And what we show is that if we select always the good equilibrium, meaning that there's no self-fulfilling financial crisis in the economy, then it's optimal to have a flexible exchange rate. So, and here the flexible exchange rate is the case where phi E goes to infinity, you fix money supply, and when phi E is equal to 0, you fix exchange rate, we have fixed exchange rate regime. So you can see here that in terms of welfare, stabilizing the exchange rate is going to reduce welfare. In particular, for the fixed exchange rate regime, which is defined the same way we define the fixed exchange rate in the theory, which is committing to the efficient level, is going to lead to a welfare loss of about 0.1% of permanent consumption. When we select always the bad equilibrium, then you can see here that by reducing the exchange of volatility, the central bank here can increase welfare. Another also good kind of insight from this graph is that it's nonlinear in phi E, meaning that there is an interior solution. fixing the exchange rate leads to welfare gains, but it's dominated by an exchange rate regime in which the central bank let the exchange rate fluctuate a little bit, but stabilizes, also reduces the volatility a little bit too. And here in our quantitative analysis, the optimal weight on the deviation of money supply from the efficient level is 1/2. And you can see that the exchange rate volatility here is also close to the exchange rate volatility on the fixed exchange rate. Okay, so now that we have this result, so what we show is that, to summarize, what we show is the following. We show that in the absence of fundamental shocks, when the economy starts with an initial debt level that is less than 1 plus kappa YT, you want to stabilize the exchange rate. We also show that even with fundamental shocks, if you always select the bad equilibrium, you still want to stabilize the exchange rate. If you are able to always select the good one, then you want to have flexible exchange rate. So what you want to do optimally is, as a central bank, is to have a monetary policy rule that will implement the flexible exchange rate regime in the good equilibrium and prevent deviation from the optimal exchange rate regime, meaning that you want to have an exchange rate regime that will prevent self-fulfilling financial crisis. And that's what we do in the last part of the paper. So I'm going to skip that because I think it's already 9. So here, what we do first is that we first try to characterize the optimal policy under discretion. And under discretion, we have the following timing. The household first chooses B prime, government chooses money supply, and then market clears and household consume. So the problem is going to be solved sequentially. The central bank, given an initial aggregate debt level, is going to select monetary policy, and household anticipate the monetary policy of the government and choose the initial debt level at the beginning of the period. Consistency requires, the markup perfect equilibrium here requires B prime for the individual household to be equal to big B prime. And what we show is that the set of Markov perfect equilibria is convex. And when the economy starts with an initial debt level or debt to tradable output ratio that is less than 1 plus kappa, then the boundaries of the Markov perfect equilibria are determined by the two equilibria under full employment. And that's what we have here. And then we use that to talk about our optimal policy. So the optimal policy under commitment is the following. If the economy starts with an initial debt level or a debt to tradable output ratio that is less than 1 plus kappa YT, you, as a central bank at the beginning of the period, you announce that you are going to commit to implementing an exchange rate level that is equal to the efficient one and not deviate from that. And we know that with this exchange rate level, it prevents the economy from entering in this crisis region. So you don't have self-fulfilling financial crisis here. If the economy starts with a debt level, if you're in the high debt level region where the debt to tradable output ratio is greater than 1 plus kappa YT, then the optimal exchange rate policy that we design is the following. It's going to be a weighted average between the level of the exchange rate, the efficient level of the exchange rate, and the optimal depreciation in the Markov perfect equilibrium. And to get an intuition for why this is going to prevent the possibility of self-fulfilling financial crisis, regardless the initial debt level of the economy, assume that the economy starts with B0 and household borrow B0 equals B1 equals B0. Aggregate borrowing is exactly equal to aggregate debt, which is the efficient level of borrowing that the central bank wants. Then according to this rule, the central bank is going to implement the efficient exchange rate, allocation is going to be efficient. If household, for some reason, believe that they're going to be deleveraging and everything will go bad in the economy, then this rule makes this decision suboptimal for the household. And to see that, assume that everybody is deleveraging in the economy, then consumption has to be low today relative to the steady state level of consumption, which is the level of consumption tomorrow. So the Lagrange multiplier is going to be positive. And because the central bank commit to not depreciate the exchange rate as much as it would on the in the Markov perfect equilibrium, then what will happen is that the borrowing constraint is going to be slack. So when you look at the complementary slackness condition of the household, it's positive, meaning that if an household thinks that everybody's going to deleverage, it has an incentive to borrow a little bit more than everybody else. And this makes this deviation suboptimal for everybody, so it cannot be supported as a Nash equilibrium. And the only equilibrium that can be implemented is going to be the efficient allocation. All right, so to conclude, here what we show is that we present a theory where the fear of floating emerged endogenously. We show that by fixing the exchange rate, the central bank can help prevent self-fulfilling financial crisis. And something that I didn't talk a lot about is the fact that we also show that a depreciation in this case can be contractionary. Thank you.
Lawrence?
It's been uploaded here.
Hello.
Does this have to be turned on?
Yes, yes.
I think I turned it on there.
All right.
And is there a clicker?
You have it. It's already printed?
Yeah, it's up here.
Yeah.
So this is just to go to Zoom and do a screen share.
How about you do it?
I also need that clicker.
No idea what it is. That one.
Is that? Is that? Is that?
Okay. Okay, yes, that's good. So,
You have to stand closer to the ears so they can hear, because that microphone is the one that works. That one goes to the stream, that one goes to me.
oh,
Sorry, that's a little bit confusing.
okay, well, thank you for inviting me to discuss this paper. I learned a lot in thinking about it, and I hope this discussion is helpful. So here's the background, is that since the end of Bretton Woods, the world, I mean, I guess supposedly moved to a floating exchange rate regime. But in practice, central banks intervened to keep the exchange rate from moving too much. I guess I'll clarify that later. And so it appears, because they're cautious about letting the exchange rate move too much, that there's some kind of fear of floating. Louphou and Javier, they suggest a reason for fear, which is that if you float, then there's a possibility that non-fundamental shocks will come over, take over your economy, and perturb it inefficiently. So what I want to do in my discussion is I'm hoping to give the basic insight in the paper, and I want to compare it to what I view as the conventional view about and contrast it. Well, okay. I want to compare and contrast it with what I think is the conventional view about all this stuff. See, this thing's clicker is not working. Yeah, now it is. Okay, so just to begin, what I have here to talk about what floating and stuff is about is that I've got this figure here. I got this from Ryan. Well, no, maybe you haven't seen it because I took their data and created this figure. And they have, they designate countries as being fixed exchange rate, or crawling peg, or crawling band, or full floaters, which is 4 and 5. I couldn't get rid of these numbers in between here. And this is a histogram over all of these countries, and what you can see is that a ton of people are in the fixed thing, and there are very few floaters. And so that's the idea or the puzzle that we're talking about. Why are people so afraid of being floaters? When we look at if you look at the names of the countries inside their data, what you see is that it's basically kind of rich countries that are floating, and they have very volatile exchange rates. Actually, this is the list of the countries, includes South Africa. And then in the other countries, however, exchange rates do move around a lot. So even though they are reported as not, I'll talk about that more in a second. There's a survey that this person, many of you probably know about the survey of central bankers, where that person found that a lot of central bankers like to meddle with the exchange markets in order to stabilize them. And their fear is that if they don't do that, FX markets would be disorderly. So this is, I guess, an idea of fear of floating. This story here is formalized in several places, but Montero and Ortiz is an example of this, where they formulate this idea about, or this quote that I gave. Here is the exchange rate for the US versus the euro, and it's extremely volatile, 20%, minus 20%. And then here's the percent changes in prices just as a baseline. Those exchange rates are very volatile, and those are the clear floaters. Now I want to look at two emerging market countries. I want to compare them. So I want to look at the Chilean peso and Peruvian soles. And what we'll see is, to my eye, but this is just an eyeball thing, at low frequencies, they both seem to be floating at low frequencies. There is a difference at the high frequencies between them, especially early in the sample. These guys talk about this. They interpret the difference as reflecting that the Chilean central bank, at least in the early part of this data set, does relatively little FX intervention. So here we have the data. The solid line, this is daily data. The solid line is Peru. So
what's the year?
yeah, this is starting, this is 2000 and going up to 2020.
Yeah, the Chileans get upset if people don't classify them as floaters.
So if I look at the blue, actually I look at both of these lines. I want to define the low frequency as kind of, not including the hairy stuff at the high frequency. And if you look at these lines, you see very substantial movements in the exchange rate. So for example, from here to there, you have, in a couple of years, a 30% depreciation of the Peruvian soles. And the two exchange rates kind of behave similarly at the low frequency. But at the high frequency, there's a bit of a difference. I guess you have to look a little bit to see it. But this is smoother at the high frequencies than the Chilean exchange rate. The way the Peruvians explain this is they argue that they, as a matter of policy, actively intervene, and I spent time with them in Peru while they were doing this. Every day at 12:30, they intervene in the foreign exchange market, and they do it precisely to get rid of these little jiggles here. And the claim is that the reason this is smoother than that this shows what it is that this is the effects of what they're doing. I think it's argued that since 2011, the Chileans are also going into the FX market.
They intervene 5 times. They intervene 5 times. They have listed it.
Okay. Anyway, the Peruvians intervene daily.
Every day.
Yeah. So now what I want to do is I'm going to do a seriously back of the envelope analysis. both of Javier and Louphou's model, and of what I think is a conventional wisdom about this. I'm going to give an alternative interpretation to what's going on here. So I apologize to the authors. Well, grossly oversimplify their analysis, but hopefully not throw out the baby there with the bathwater. And what I want to do is I want to compare the position that they take in their paper with what I think is a more conventional view about what we saw, for example, about Chile versus Peru. It's a little bit like what's in the Ortiz and Montero paper, and it's a lot like what I understand from the IMF's integrated policy framework, more specifically Chris Ursig and Jesper Linde's stuff. Now, I'm going to do this in a crazy simple model. This is the only way I know how to, I spend a lot of time with complex models, and they desperately require trivial back-of-the-envelope things in order to understand that, and I hope that I'm going to do that with this model. So I'm going to take the Krugman and Obstfeld's sort of simple stuff, and that has financial markets and goods markets in it. And what I'm going to do is talk about what they do, how do they get fear floating, and how I think the IMF gets fear floating. Okay, so the thing has financial markets, and most of you probably have already seen this. The model has financial markets, and there are two types of financial markets. There are international financial markets, and then there's financial markets that involve the purchase or the acquisition of money by the local people. And the money acquisition is just a static money demand equation. You actually have that in this model as well. Static money demand equation, where money demand goes down, interest rate is high, money demand goes up, and output is high. The international financial markets, I'm assuming free capital mobility and risk neutrality on the part of the bond traders, and that delivers the familiar UIP equation. This is the anticipated exchange rate depreciation, domestic interest rate, foreign interest rate, and then there's this little row guy that will be at the risk premium term that I'm going to talk about it implicitly but not explicitly. This is the financial thing. In this model, there are three endogenous variables: R, domestic interest rate, exchange rate, and output. So we obviously need another equation. M is going to be set by the monetary authority, and actually they can also move this row around, but as I said, I'm not going to talk about that. That'll be called FX intervention. But M is set by the monetary authority, and I'm going to have two versions of this policy, which I think corresponds to what Louphou was talking about. There's a floating exchange rate regime, which is where I just fixed the value of M. It's just constant. And then I have a fixed exchange rate regime where I adjust M so that the fixed exchange rate is realized as an equilibrium. So if I look at the financial markets, they can be very similarly, they can be simply summarized by what they call the AA curve. So the vertical axis I have an exchange rate, the horizontal axis I have output, and the curve is just the combinations of these two things that cause both financial market things to be satisfied. So in particular, if you go to bigger Y, you get more money demand, and then in order to clear the money market, you need a higher interest rate, and then with a higher interest rate, your currency appreciates. So you get this relationship, and that's in the AA curve that summarizes the financial markets. Then the goods markets are, when they're in equilibrium, the amount produced is equal to the amount people want to purchase, given the amount produced. That amount produced goes to them fully in the form of income, and this is their decision about what to do when they get that income. I'm going to have consumption as a function of disposable income. Investment is exogenous. G is exogenous. And here's the net exports. It's increasing in the real exchange rate. I have P star and P, that's the foreign price, this is domestic price. Both of these guys are fixed in this analysis. And then this is increasing, or rather decreasing in Y minus T. So then the way you summarize, well, here's the graph of the guy. Now, I'm going to go back to this graph later, so I want to do it now. So here I have a graph of D as a function of Y, conditional on some random variable value of the exchange rate. So conditional on some value of the exchange rate, this thing is an upward sloping curve. And if I depreciate the exchange rate, I make it go up, then because of the way this thing is structured, because of the effect on the real exchange rate, this whole thing shifts up. And the equilibrium now is higher. So that's why we get a positively sloped graph with the E and Y combinations. That's called the DD curve. Okay, so in equilibrium, you have the intersection of these two curves, and this is kind of the equilibrium level of exchange rate. Now, if you look at this thing, now sort of imagine shocks in this model. So in DD, there could be shocks to investment. I will move it around. Government spending. Even the consumption function could shift around. Current account could shift around. Foreign price, foreign interest, not foreign interest rate, but that would make this curve shift back and forth. And the AA curve is a function of what people anticipate the exchange rate to be in the future, which I'm taking as exogenous for now. It's a function of rho, that thing. It's a function of money demand, all that stuff. And as those things jiggle around, they don't affect this curve, but they move this curve around. And so then you can see here that if you want to stabilize output around, say this is the full employment level, then what you want to do with the exchange rate depends on where the shocks are. If the shocks are in the AA curve, then you want to fix the exchange rate. If the shocks are in the DD curve, you want to let the exchange rate float, because then the exchange rate stabilizes the economy. Here's a quick graph of this thing. So here's the AA curve moving around. If you keep the money supply stuck so that you're floating, then the exchange rate depreciates when this A curve shifts to the right, and it prevents you from, say, having this huge increase in output, right, and give you this instead. Similarly, if when the shocks push the AA curve down, then a fixed exchange rate would get output to go all the way down there, but the floating exchange rate stabilizes. Okay, and so yeah, this is just what I said. Okay, now let me talk about the convention. What I think is the conventional story about stuff. So the financial shocks, I think, are conventionally thought of as very high frequency shocks. They happen on a frequency of hours or days. And people like the people in Peru that I know who go on the floor and do stuff, what they're doing is they're trying to get rid of the blips in the exchange rate, and they look like they do. And generally I hear the same story told all the time, that it's good to have the central bank in the exchange market at noon every day, or 12:30 maybe, because the financial markets are very thin. You know, some big copper magnate could show up wanting to take profits out of the country on a particular day, and there are not many traders around, so the exchange rate might move a lot, and so the central bank goes in there to clip those kinds of things. Now, goods market shocks occur over a completely different horizon. They operate over months or quarters or maybe years, and this is the conventional view, I think. There's no point reacting to those shocks by fixing the exchange rate, because that only exacerbates the shock. So I think this is the conventional view. You want to clip the high frequency stuff, and the low frequency stuff is coming primarily from the goods market. Now let me talk about Xavier and Louphou's story. But I think I would probably a gross oversimplification, but now it's hiding underneath, it's behind this thing. I don't know if I can move.
Yeah.
Is there any way to move that? Oh, you can move it up maybe to the top. So I think that the way to tell their story is like this. Yeah, no, that was okay. Oh, okay.
No, is it the
There's a thing that you can put, don't you? Isn't it?
Yeah, you can hide it. You can hide it.
Yeah.
If you go over to the
You know how to
more,
hide it?
there's a hide floating controls. Okay, so now let me talk what I think is their insight. But again, grossly oversimplifying, and I have no intention here of telling you that they should have done it in this simple way, because unless you dot all the I's and cross the T's, no one really knows. You're going to see me not dotting any I or crossing any T. Okay, so remember I talked to you about how when the exchange rate this is the demand for goods from the economy as a function of output, and then I fixed the exchange rate to, just because I need also the financial markets to actually pin down the exchange rate. And what I said was that if you increase E from E to E prime, then this curve shifts up, and that's called the expenditure switching channel. That's the expenditure switching channel. Now, they have another channel, financial channel. The other channel they have has the property that when you increase E, you reduce the ability of a bunch of people to spend stuff. In particular, the way to think about that is suppose that in order to buy, and the way they think about it, suppose that in order to buy stuff, you had to borrow something from abroad. You could be a firm that requires chips or something from abroad, and you need to borrow dollars in order to get those chips in order to produce. So if the exchange, suppose that there's some kind of a constraint like Louphou was talking about, that when the exchange rate depreciates, you can borrow fewer, you're just restricted on how many dollars you can borrow. And so what that means is that that's going to depress this D curve, because part of the D curve is investment, part of it's consumption. It could be the households that need to borrow. I actually don't know. It doesn't matter who they are. But this E going up could reduce this D curve. By the way, once you start talking like this, there are like a million reasons why this would happen. For example, people could suffer capital losses when the exchange rate depreciates. Anybody who's borrowed abroad, they will suffer a capital loss because their debt now is bigger in domestic currency terms. So think about it however you want. But the idea is that the exchange rate going up has not just a positive effect through the expenditure switching mechanism, but also a negative effect through this financial mechanism. And let's suppose that the financial effect is bigger than the expenditure switching effect. By the way, people have argued that this expenditure switching is really vastly overblown because of dollar pricing, whatever. So it may very well be that reversing the sign of this thing may not be that difficult to do in practice. So now, when you raise the exchange rate, since you now have two things impacting on purchases. One is expenditure switching, maybe that shifts this thing up. And the other one is that the rise in E shifts the thing down because of the tightening constraints. And let's suppose the downshift is bigger than the upshift. Okay? Now, so now what you have is that when E goes up, what I now have is a lower equilibrium level of output. This is a contractionary depreciation. It's contractionary because the rise in the depreciation in the exchange rate is causing a bunch of people to have to spend less. As a consequence, what happens is that the DD curve is no longer upward sloping. It's now actually downward sloping. You know, as you appreciate, you have a contractionary effect. As you depreciate, you contract the economy, and so you now have a downward sloping curve. Okay, something stopped. Oh, okay, yeah. Okay, so the story that Javier and Louphou are telling is that, my interpretation, my back of the envelope interpretation, is that they now have both of the curves, the AA curve and the DD curve, are both downward sloping. Once they're both downward sloping, all kinds of action can happen, including, for example, in fact, if you just write this thing model down randomly, you will get this kind of result. You would probably write down a linear DD, and you would have a convex AA because of the uncovered interest parity condition. So let's suppose it looks like this, and then you can see here I've got two crossings. And you know, you have one equilibrium here, you have another equilibrium there. And it's a self-fulfilling kind of thing. So if the exchange rate is appreciated on one particular day, this is an equilibrium. Now suppose that tomorrow everybody thinks that the exchange rate is going to depreciate. Well, if they think the exchange rate is going to depreciate, they're going to buy less stuff, right? That's the assumption, that depreciation cuts back on expenditures. If they buy less stuff, then output is going to be lower in the economy. If output is lower in the economy, money demand is lower. If money demand is lower, then the interest rate goes down and the exchange rate depreciates. So very, very simple logic here. I imagine it's possible to construct stochastic equilibria that have you choosing one or the other, probably a continuum of stochastic equilibria that select between those two. So to sort of summarize and conclude, they argue that what policymakers may be afraid of is that the economy will become subject to sunspot equilibria. Notice that their sunspot equilibria are costly because in the model they make output fluctuate. You know, your whole economy is getting dragged one way, then the other way as you jump between these two things. So their conclusion is that what they fear about floating is that you could start fluctuating for non-fundamental reasons, and it's better to fix the exchange rate and pick one of those two, or maybe another one if it's welfare superior. Now, I want to say that multiplicities often show up in sticky price models. They're hard to find because this is not what's called equilibrium indeterminacy. This is these are determinate equilibria. They're isolated equilibria, and it's very hard you can't find them using Mr. Blanchard and Mr. Kahn's trick. But when people look at this very closely, for example, they typically, in the New Keynesian type models, that if you impose on the model a robustness, if you impose on an equilibrium a robustness requirement, a particular robustness, in particular, that the equilibrium is learnable. You don't have to be 100% rational, so to speak. Even if you're a little bit off, you want the equilibrium to have the property that you will cycle into it. And typically, one equilibrium is not robust and the other one is. The one that's not robust would be viewed as a curiosity, but not something that an actual economy could ever reach. I don't know what that looks like here, and this issue about learning in the context of this model. The other thing is that with multiple equilibria, I don't know if you're familiar with the Laffer curve, but the Laffer curve, what happens is the dynamics of the model are completely different when you're at one equilibrium or the other equilibrium. And if you look back at my graph of the DD curve and the AA curve, you can see that everything moves around in a different way depending on where you are. If you shift the curves, behaves very differently. And I don't know whether in this model the local, you shock it up. If you do it around one equilibrium, does it look very different from the other equilibrium. Now then, I also have, is there a compelling reason to think that this is what's going on? And I just don't know. I mean, it's hard. I don't know. And these rich floaters, why don't they have that problem? Why don't they have the problem? The rich floaters should have the problem in spades. Okay, that's it. Thank you.
Thank you. Yes, maybe. Yeah,
Since I'm
please.
here, I'll take some.
If you can just,
Thanks so
Come.
much, Larry. This was a really outstanding discussion, very, very insightful. And so I like a lot the DDA model. I took that as an undergraduate and still do that model sometimes. So I agree that in that model, whether you have shocks that are of course monetary or real, depends on what answer you want to choose. So in a way we think about our paper as sort of generalization of this full type of framework, where now instead of thinking about monetary or real shocks, we think about transport shocks when you have this possibility of indeterminacy. Our point is basically once you consider this type of shocks, what you want to do is fix the exchange rate. And we think the basic model without this type of shocks do not get quite the facts that we see in the data. For example, you think about comparing emerging versus developed economies. You may think that, well, maybe what's going on is that emerging economies have more monetary shocks, and that's why they fix the exchange rate. But then, if the point is that there are more monetary shocks, then you will also observe nominal rates to be, you will see emerging markets trying to affect the nominal rate to offset also the monetary shocks. But we don't see that. We see central banks also moving interest rates quite a bit in a way to try to keep the exchange rate sort of from fluctuating too much. The financial shocks, they're a bit more tricky because I don't think they are. You can argue that they are necessarily so high frequency. Like we've seen, for example, after the global financial crisis, CAP deviations that lasted for a long time, years after the even
Not in emerging markets. In Chile,
when
they have.
in emerging markets, I don't think we measure them so well. But the point is that these financial factors can last for a long time. So
No, I think that's not. It is pretty weird that the CIP deviations are on the order of 75 basis points still today.
yeah.
And I think the standard interpretation of that is the regulations that regulators stop people from pulling the arbitrage.
Oh, fair enough, but there may be some like us that maybe could also do it. So there's some frictions there that if they're operating now, we don't have the regulation. So I think that still suggests that financial factors can have long-lasting effects. In terms of the mechanism, how prevalent it is, how important it is quantitatively, of course, this is a very stylized model, and try to build a simple model to try to make a point. But I think the ingredients we put in the model are fairly standard. You put plausible parameters, and you get this mechanism in the model. So I think it could be quantitatively important. And then the last point was about the comparison of the multiplicity models. That I'm not so sure that it's so similar in the sense that at least the way I think about multiplicity in model is that you have a nominal indeterminacy because of certain equivalence type of reasons. And so the Keynesian model, inherits some real indeterminacy because of that. But if you think through the standard Keynesian cross logic, that will tell you the degree of unit, because you have higher income, consumption does not increase by the same amount. So I think it's the sort of multiplicity is a little different, so we need to think more about how the results and simplicity becomes a more
Well, the Laffer curve is another, you have multiple isolated equilibria. But the Duquesne model has tons of equilibria, not just the indeterminacy, it has many equilibria. And, but there you find that the properties of the two are very different, and, or more than two, actually, I found 6. But the non-standard ones typically cannot be learned. So I don't know whether.
Yeah, actually, when we do the Markov perfect, we find a whole continuum of equilibrium. There's a whole complex set that Louphou didn't spend much time. But once you have a government that is optimizing without commitment, that opens the space of multiplicity immensely. And,
Great.
So the way to fix it here is by committing to one exchange rates.
Great. Thank you very much. It was a great discussion, great paper. Thank you. Great day. Thank you, Louphou. Can you? I hope you could follow the discussion and the paper. Thank you very much for being with us. Take care. Take care. Ciao. Ciao. Allora, okay. Thank you. It was a great day.